Hi everybody, this is Miss Holden, and this is a video for the review for Chapter 9 for Geometry. So you guys have worked on this review sheet hopefully for 2 days already, and you're just checking your answers right now. The nice thing about the video is that you can fast forward it. I'm going to put a hard copy on the website of the answers as well, so if you want to look through them, and then you can just watch the part of the video that you maybe had a trouble with some questions, or you can rewind if I go too fast and listen to it a second time. So the first three questions are dealing with the properties of quadrilaterals and parallelograms. So the first question says, name the figure that have perpendicular diagonals. So a rhombus has perpendicular diagonals, and a square is a rhombus also. A square just also happens to have right angles, if you remember our family tree of parallelograms. But the answer is rhombus and square. Figure that has congruent diagonals are the rectangle and the square. And if you draw a rectangle and a square and then draw the diagonals, you can see they look like they're the same length. Whereas if you had a parallelogram and a rhombus, because it is sort of like flopped over a little bit, those diagonals, one winds up being longer than the other. All right, so the Regents does ask questions dealing with the properties of these parallelograms. Diagonals are definitely a big thing that's asked. And then the figures that have diagonals that bisect each other, that's a property for a parallelogram. And since a rectangle and a rhombus and a square are all parallelograms, they are included also in the answer. All right, question 4 deals with partitioning. Now, how do I know that? So if you see the word partitioning or dividing, see how I highlighted this word dividing? I'm dividing a segment with endpoints A28 to B73 into two segments with a ratio of 4 to 1. So if they have a 4 to 1 ratio, so it's 4 to 1, okay, 1, oops, sorry. I was trying to put my fingers on the screen there. There's 5 parts total, so a ratio of 4 to 1, there's 5 parts. So since there's 5 parts, I need to take this ratio and convert it to a decimal. So 4 is the first number that goes in the numerator, and then you add the 4 and the 1 because there's 5 parts total that goes in the denominator. So my fraction is actually 4/5. My partitioning formula is right here. I copied it down for you. And when you take a test, you're going to have your notes right there, so you don't have to memorize anything at all for the test. So x1, which is 2, plus 4/5, x2 minus x1. This formula is important that you are doing x2 minus x1. For slope, it's not necessarily important to start with the x2 and the y2, but it's important to be consistent. Here you actually have to do x2 minus x1. So 7 minus 2, and then you do the same thing for the y's. Y1, which is 8, plus a over b, that's my fraction, 4/5, and 3 minus 8. And this whole thing can go into your calculator here, and you get your x coordinate. My x coordinate comes out to be 6, and then this whole thing can go right in your calculator exactly the way it's written, and you get 4. Okay? Next question ties together a lot of stuff that we learned in geometry. We're writing an equation of the perpendicular bisector of a line segment joining the points A, 3, 5, and B, 9, -1. Now I have a lot of stuff highlighted here. An equation of a line, we just did that recently, y minus y1 equals m parentheses x minus x1. But it's a special kind of equation. It's an equation of the perpendicular bisector. So as soon as you see bisector, I'm cutting it in half. So I immediately think midpoint. I have to find the midpoint of A and B. So I add the x's, divide by 2, and I get 6. And then I add the y's and I divide by 2 and I get 2. It's also perpendicular. So you guys need to know that perpendicular lines, their slopes are negative reciprocals. So I find the slope of AB, y2 minus y1, -1 minus 5, over x2 minus x1, 9 minus 3. So that gives me -6 over 6, which is -1. Now the perpendicular slope, you got to flip it and you got to change the sign. So since this is -1, when I flip it, it's going to stay 1, but then I have to change the sign. So my perpendicular slope is 1. And then look, all I did was I took this point 6,2 and I put it in for x1 and y1, and I took my perpendicular slope right here, 1, and I plugged it in for my slope. That's my answer. I don't even need to simplify or do anything with that. Question 6, I have a parallelogram. You can draw a parallelogram if it's going to help you out. these are my points, W, X, Y, Z, and they tell me the diagonals W, Y, and X, Z intersect at E. Find the coordinates of point E. So one of the things that we learned, or that we answered actually right here, is that the diagonals bisect each other. Since they bisect each other, then that means that E is actually going to be my midpoint. So all I'm doing is I can find the midpoint of WY or XZ. It doesn't matter which one, but you need to make sure that you're finding the midpoint of the diagonal, not the midpoint of a side. So again, it's WY. So I add the X's, divide by 2, I get -2. And then I add the y's and I divide by 2 and I get 1/2. If you had done it with xz, you would have gotten that same point because those diagonals are, they're meeting right there in the middle. That's another way that I can use to prove something is a parallelogram, by showing that the diagonals have that same point, that same midpoint, that they bisect each other. Question 7 is dealing with a rhombus. Remember, in a rhombus, my diagonals are perpendicular to each other and they bisect each other. So when they told me my diagonals have a length of 18 and 24, so instead of writing 18, I can write 9 and 9. I just wrote one of the 9s here. And instead of writing 24, I got 12 and 12 because they bisect each other. It's perpendicular, so this right here is a right triangle. And I'm going to use my Pythagorean theorem to find the length of that side. So 9 squared plus 12 squared equals x squared. Remember, the side that's across from the right angle, this x, that's my hypotenuse. This is 81 plus 144, which is 225, equals x squared. And then I take in order to solve for x, I'm going to take the square root of 225, which is 15. Now that's not the answer because the question actually said to find the perimeter of the rhombus. So perimeter means I need to add up all the sides. So 15 plus 15 plus 15 plus 15, and that equals 60. Okay. Next one, it says, what is the length of CD? Now, length is going to be using your distance formula. So I wrote down my distance formula here. So I'm going to do, it can either be x1 minus x2 or x2 minus x1. The important part is that you are consistent with what you're going to do. So I did 2 minus -5 squared plus 13 minus 3 squared. All right, and be careful with your minus negatives. This is 7 squared. 13 minus 3 is 10 squared. So that's 49 plus 100 is 149. And I take the square root of that, which is 12.2. So that is choice 4 right here. Okay, I didn't circle that one. All right, that's page 1. Second page, number 9, they give me a circle. They give me the center of the circle, and they give me one of the points on the circle, and I want to find the length of the radius. Notice I highlighted the word length right there. So length of the radius, I'm using my distance formula. Okay, so again, 3 minus -2 squared plus -1 minus 7 squared. So that's 5 squared plus -8 squared. Now, I know this is -8, but I'm squaring it, so that's going to be positive 64. So just be careful with your calculator with that. All right, and this one we get to leave as a radical. We leave it as a radical 89. 10, I have another partitioning problem, but it's actually not, because I'm going to partition it into 2 congruent segments. So actually, that's just the midpoint. I can use my partitioning formula and use a fraction of 1/2, but it's definitely easier just to use my midpoint formula. So I add the x's, divide by 2, add the y's, divide by 2, and my answer is 6, -5. Okay, again, anything that you're having a little trouble with, try and rewind it. See if you can figure that out. Now, 11 is a midpoint question, except it's a different midpoint question in that they give you the midpoint. So I'm going to show you how I do it here, and then I'm going to show you how you can do it on the graph if you want to. So the midpoint of CD is 4, 3. So 4, 3 is the midpoint, is the point in the middle. C is the point -2, 7. And I'm trying to find the coordinates of point D over here. The midpoint has to be the same distance away from C as it is from D. So what I do is I'm looking at the x coordinates and trying to figure out, well, how far away is it? What did I do? Did I add? Did I subtract? To go from -2 to 4, I added 6. To go from 7 to 3, I subtracted 4. And whatever you do, I have to do the exact same thing on this side. So 4 plus 6 is 10, and 3 plus -4 is -1. So that's my answer. If I put my midpoint here, 4, 3, and I put point C here, -2, 7, you can sort of just count over. I went over 6 and down 4, and I do the same thing, over 6 and down 4, and there's my answer, 10, -1. So whatever you feel more comfortable with. If there is no graph paper, you can always use a piece of scrap graph paper. On the Regents, there'll be graph paper, scrap graph paper that you can use if you prefer to do it graphically. Here's just a multiple choice question about diagonals and parallelograms. It wants to know what condition would you need for the diagonals of a parallelogram to guarantee that it's a rectangle. Now, they do bisect each other, but that doesn't make it a rectangle. That's just true for parallelograms. Perpendicular is for rhombus. They are the same length. That's the answer right here. If I have the diagonals of a parallelogram that happen to be the same length, then it's going to be a rectangle. All right. This wants to know which would not be sufficient to prove that EFGH is a square. All right, so EFGH, I drew EFGH for us, and I want to know what would not be sufficient to prove it's a square. So choice 2, EG, which is a diagonal, is congruent to FH. All right, so that's true for squares, but it's also true for rectangles. So let's see if there's something else that would specifically make it a square. And EH is congruent to FG. EH is congruent to FG. Again, that would also, opposite sides being congruent would also be true for rectangles. It's not necessarily going to make it a square. It would not guarantee it's a square. Okay. Next page, number 14. That's another one that was similar to where I give you the midpoint and you have to find the other endpoint. So a circle has a center of 5, -1. The diameter has one endpoint of 2, 3, and I'm trying to find the coordinates of this other endpoint. So what I did is I said, all right, if this is the midpoint, however far away it is from 2, 3, it's going to be the same distance away from that other endpoint. So I looked at my x coordinates. How did I get from 2 to 5? Well, I added 3. I looked at my y coordinates. How did I get from 3 to -1? Well, I subtracted 4. I need to do the same exact thing on the other side. So 5 plus 3 is 8, and -1 minus 4 is -5, and that's my answer. 15, I am dividing or partitioning a segment into a ratio of 3 to 1. So again, if I have a ratio of 3 to 1, so I got 3 to 1, all right, I've got 4 parts total. So my fraction is going to be 3/4. So x1, which is 2, plus a over b, 3/4, parentheses, x2 minus x1, 10 minus 2. And then the same thing with the y's. y1, which is 8, plus 3/4, y2, -4, minus 8. And I do this whole thing on the left part in my calculator, and I get 8. And I do this on the right, and I get -1. 16 rather, is another equation of the perpendicular bisector. So I have everything highlighted just like I did before. Equation of a line is y minus y1 equals m parentheses x minus x1. A bisector is the point in the middle, the midpoint, so you need to find the midpoint. I add the x's, divide by 2. I add the y's, divide by 2, and my midpoint is 4, -2. And then perpendicular lines, the slopes are negative reciprocals. So I am finding the slope of AB, y2 minus y1 is -10, x2 minus x1 is 6, and I did reduce it, and technically it didn't say I had to, but I did. Now I want the perpendicular slope, so I have to take that -5/3 and I need to flip it, all right? And then you need to change the sign, so that's gonna be positive 3/5. All I did was I took this midpoint, 4, -2. See how 4 went in for x1 and 2 went in for y1, except it's y minus y1. So y minus -2, that's why it's plus 2, and x minus x1. And then my slope was 3/5, and that's my answer. 17 is a coordinate geometry proof. I want to show that the ABCD is a parallelogram using the midpoint formula. So basically, I need to show that the diagonals bisect each other by finding the midpoint of the diagonals. So you don't have to graph these out. It's always going to say that the graph is optional. But when you do graph it out, you can see which points would form the diagonal. So I'm going to find the midpoint of AC. I add the x's, divide by 2, add the y's, divide by 2. And then I'm going to find the midpoint of BD. Again, I'm going to add the x's, divide by 2, add the y's, divide by 2. Since they have the same midpoint, that means they bisect each other. And if the diagonals bisect each other, then ABCD has to be a parallelogram. 18 is a long one because I have to prove it's a rhombus. The thing about a rhombus is that all sides are congruent. So basically you have to do the distance formula 4 times. And I know that's kind of annoying to do. But I'm finding the length of AB, BC, AD, and CD. All right, notice they all have the same lengths. Now this is a problem where it's not hard, it's just time consuming to do. You need to be neat and organized. You can't have numbers scattered across your page and not say what you're finding the length of. So see how everything's AB and I do AB, BC, I do BC. You don't have to simplify these radicals as long as they're all the same, then that's showing that it's a rhombus. So they don't need to be simplified, I just leave them all as radical 50. And since all the sides are congruent, then ABCD is a rhombus. All right. Next page, we have some more coordinate geometry proofs. In 19, I'm showing that it's a rectangle. Now, a rectangle has opposite sides parallel, and it has a right angle. So I can do all of that just by doing the slope 4 times. Again, if you want to graph it, if it's helpful, then go ahead and graph it. I did not graph this one. You don't get points for graphing, but if it's helping you, then great. You get points for all this work right here. So I'm finding the slope of all 4 sides. I find the slope of AB, y2 minus y1 over x2 minus x1. I do want to reduce just so I can see that these opposite sides actually have the same slope. BC is, my slope is a 3 over negative 1. CD is 3 over 9, which I forgot to reduce, but you can see that these are the same right here. AB is parallel to CD. They have the same slope. AD slope is 3 over negative 1, and see how AD is parallel to BC. So the opposite sides both have the same slope. And the sides that are next to each other, look at this, their slopes are negative reciprocals, which means it has a right angle. All right, so it's a parallelogram because the opposite sides are parallel, they have the same slope, and it's a rectangle because it has a right angle. I forgot to write that. It's a rectangle because they have a right angle because those slopes are negative reciprocals, so I would just need to add that on. Okay, 20 is another one of a perpendicular bisector equation. So equation of a line is y minus y1 equals m parentheses x minus x1. Bisector means that I need to find that midpoint because a bisector cuts it in half at that midpoint. I add the x's, divide by 2, add the y's, divide by 2. And slope, it's perpendicular. So I find the slope of KL, y2 minus y1 over x2 minus x1. And my slope is negative 1/4. But since it's perpendicular, I have to flip it and change the sign. So when I flip it, it's 4 over 1. I just don't have to write that 1. All right, so to write an equation of a line, remember you need 2 things. You need a point and a slope. The point is my midpoint. The slope is my perpendicular slope. So I plug in the 4 for my slope, and I plug in 1 for x1 and 3 for y1, and that's my equation of the line right there. Y minus 3 equals 4, parentheses x minus 1. All right, 21 is another coordinate geometry proof. So in 21, they want me to find the slope of AB and CD. So I do that. Slope of AB is negative 5/2. Slope of CD is also 5 over negative 2. Now it doesn't matter if the negative's with the top number or the bottom number. If one of the numbers is negative, then the whole thing is negative. So you can see that AB and CD, which are opposite sides, have the same slope, so they are parallel. They then want me to find the length of AB and CD. So length means I have to use my distance formula. So I find the length of AB by using my distance formula, x2 minus x1 squared plus y2 minus y1 squared. So I get radical 29. And they want me to find the length of CD, which is the same thing, x2 minus x1 squared. Make sure you're using the right points when you do these. If it helps you to write above them x1, y1, x2, y2, if you find that helpful to do, then please do that. And you can see that when I find the length of CD, I get the same length. So what does that tell me about ABCD? But basically it is a parallelogram because, let me just move this up a little bit. It's a parallelogram because one pair of opposite sides are both parallel and congruent. So AB and CD are parallel and AB and CD are congruent, and that makes it a parallelogram. I think there's another part on this next page. I want to show it's a rectangle. So basically, if I can show that sides that are next to each other, their slopes are negative reciprocals, then it's a rectangle. So if I just scoot back here just for a second, I just want to, the slope of AB was negative 5/2. So AB is right here. If I can find the slope of BC and it's negative reciprocal, then that means that's a right angle. So a parallelogram with a right angle is a rectangle. And the slope of BC actually comes out to 2/5. So in fact, they are perpendicular, so ABCD is a rectangle. 22 wants me to show that the diagonals are perpendicular. So I find the slope of RT right here, and I find the slope of SU, which is right here. They are in fact perpendicular. This is negative 1/2, and this is 2. Again, my slope formula is just y2 minus y1 over x2 minus x1. If there's anything at all that I'm going too fast on, you can just rewind it. That's the nice thing about the video. If there's anything you don't need to see, you can fast forward through it. So these are perpendicular because my slopes are negative reciprocal. So as soon as you see anything about parallel or perpendicular, immediately you should be thinking about using your slope formula. And now I want to show they're congruent. So anything that has to do with congruent or the same length or equal, that you're using your distance formula. All right, so I'm finding the length of RS and the length of ST. Now RS is right here and ST is right here. They're next to each other. They actually have the same length. Okay, they both have a length of radical 65. So part C is saying, given that it's a quadrilateral, the diagonals are perpendicular, you immediately start thinking, hey, maybe it's a rhombus. And the two sides that are next to each other are congruent, and they want to know, why isn't it a rhombus? Because if you look at the picture here, it definitely doesn't look like a rhombus. Well, it turns out that kites also have diagonals that are perpendicular, and they have two sides that are next to each other are congruent. So this is not a rhombus, it is a kite. 23 wants you to prove it's a rhombus but not a square. So to prove it's a rhombus, you have to prove that all the sides are congruent. Again, that's the long one. You have to do the distance formula 4 times. So as soon as you hear rhombus, you're thinking, okay, a rhombus has all 4 sides congruent. Let me do my distance formula. Okay, so that's the long one. They all have a length of radical 130. You do not need to simplify this. All right, they all have a length of radical 130. And then they want you to prove that it's not a square. If it's a square, sides that are next to each other, their slopes would be negative reciprocals. So I just found the slope of two lines that were next to each other. I found the slope of LM, y2 minus y1 over x2 minus x1, and I got negative 7/9. And then I find the slope of MN, and that was negative 11 over negative 3. These are not negative reciprocals. Okay, so you do need to sort of write something just to show or that you understand everything, that all this work here. Basically, it is a rhombus because all these sides are congruent. So you could just say all the sides are congruent, so it's a rhombus. It is not a square because there's no right angle. The sides that are next to each other are not perpendicular to each other. And that would be enough to prove that it is not a square. Okay, and that's it. All right, so if there's anything you didn't understand, try and look back on it. You're going to be doing your test, so the test will be on the website. There'll be a link for the test. So this is Friday, probably Friday about 12 o'clock, so you can work on start. There's 2 parts to the test. One is the link on the website, and that's going to take you to a Google form to answer some questions, use your notes. And the other part of the test is on Delta Math. So make sure that you've created an account on Delta Math. That part of the test might be a little bit easier. So if you want to do that one first, just to make sure that you're understanding everything, because on Delta Math, if you're doing a problem, if you click right above the problem on the top right above the problem, it says show example. So if you're stuck, they'll show you a similar example with different numbers, and then you just go back to your original problem and try it. So you might want to do that first, the Delta Math, and then the link on the school website, cimath.com. Both of those are due on by Tuesday night. So you have through the weekend and you have Monday and Tuesday to do that. Okay, I hope everybody's doing well, and we'll see you later.